Hi, welcome to the second day of 5.2. Today we're going to learn about using cosine of a minus b, and we're also going to review a little bit about the linear combinations of sines and cosines again. And we're going to go a little bit farther also with the sines and cosines. Now, if I have this 3 cosine theta plus, or minus 7 sine theta, um, we really can't figure out what the values of theta are if there are cosine and sine. So what we need to do is write this in a way that there's only one trigonometric ratio. So remember, yesterday we learned how to write these as one sine. So to convert that, cosine moves it in the x direction, the sine moves it in the y direction. And to find our new amplitude, I use Pythagorean theorem, 3 squared plus 7 squared equals c squared, which is 9 plus 49 is equal to c squared, so that's going to be 58 is equal to c squared. So this is going to be the square root of 58. So square root of 58 cosine of theta minus, well, if we look at this, since this is in the fourth quadrant, we could just take the inverse tangent of negative 7 over 3, and that value, inverse tangent of negative 7 over 3, that value is negative 66.8. And since that's right in that location, we don't have to add or subtract 180 from that. But when I put it into the equation, I have theta minus a negative, which would be plus 66.8. Now that's equal to 6. So now we want to solve this for theta. So we want to divide by root 58 on both sides. So I have cosine of theta plus 66.8 is equal to, now I'll do it on my calculator, 6 divided by the square root of 58. That's 0.7879. And now I take the arc cosine of both sides, so theta plus 66.8 is equal to the arc cosine of 0.7879. And remember, the arc cosine is plus or minus the inverse cosine plus 360n. Now the inverse cosine of our previous answer is 38 degrees. So theta plus 66.8 is plus or minus 38 degrees, and it's 0.01, so 38 is good, plus 360n. Now I'll subtract 66.8 from both sides, and I have 38 minus 66.8, which one answer is going to be theta equals negative 28.8 plus 360n. My other answer is going to be negative 38 minus 66.8, which is going to be negative 104.8 plus 360n. Now I believe the question said solve algebraically and then find theta between 0 and 360. So neither of those answers are acceptable, but if I add 360 to them, I'll get 331.2, and over here I get 255.2. So those are the two values between 0 and 360 that will work for this equation. Alright, here's another one. Try it on your own and see how well you do. Alright, if I do this, I go 5 to the left, 2 down, and so I have 5 squared plus 2 squared is equal to c squared, so 25 plus 4, so that's going to be the square root of 29. So I have the square root of 29 cosine x minus blank equals 4. Now, since it's x, we're going to have this in radian mode. I'm going to look for, we know tangent of x, it's going to be opposite over hypotenuse, or opposite over adjacent, which is 2 over 5. So I take the arctan, which is inverse tan plus pi n. The inverse tan of 2/5 is 0.38. So if I add pi n to that, we know 0.38 is going to be up here. So if I add pi to that, I get 3.5. So it's minus 3.522. Alright, now we just have to do the algebra to figure out the values of x between 0 and 2 pi. First thing I do is divide by root 29. So I'll have cosine of x minus 3.522 is equal to 4 divided by square root of 29, and that's 0.7428. And now I take the arc cosine of both sides, so x minus 3.522 equals the arc cosine of 0.7428, which is plus or minus the inverse cosine, 0.7428 plus 2 pi n. The inverse cosine of that answer is 0.7336, so plus or minus 0.7336. Oops. And if I need an equal sign in there, if I add 3.522 to both sides, let's see where I get. X is equal to 0.733 plus 3.522, and that gives us a 4.256, let's say, plus 2 pi n, and the other one is going to be negative 0.73358 plus 3.522, which is going to be 2.78. Let's say 2.789. Oh, 88. He's actually right. Plus 2 pi n. Alright, so the values are between 0 and 2 pi. So that's between 0 and 6.28. So if I add 2 pi or subtract 2 pi from each of those, I'm going to be out of my zone. So it's going to be 2.788 and 4.256. Alright, those problems are done. Now, we don't need an exploration. We can just look at our calculator. Take the cosine of 58 minus 20, which is 38, and see if that equals the cosine of 58 minus the cosine of 20. I'll put a question mark on that equal sign. Well, the cosine of 38 degrees is 0.7880. Cosine of 58 minus cosine of 20 is negative 0.40977. Obviously not correct. So these are not equal statements. So we can't just use the distributive property with cosine. Now let's look at each value. Cosine of 58, cosine 20, sine 58, sine 20. This value is 0.5299. This one is 0.9397. Sine of 58 is 0.8480. And sine of 20 is 0.3420. Well, if you look at these values, trying to get 0.78 would be kind of tricky. Well, what if we multiply these two and then multiply these two? So 0.5299 times 0.9397, that equals 0.4979. And over here we have 0.8480 times 0.3420, which is 0.2900. What can we do with these values? Well, if we add them up, we'll get about 60, 78, 79. So that's about 0.78, which is about what this answer should be. We said this is about 7.788. So there was, of course, some rounding near the end there. So this would be how we do it. We take our cosines, multiply those together. Take our sines, multiply those together. Cosine of each, sine of each. And then we add those together, and then we get the answer. It's pretty crazy. All right, now we go to, it looks like a completely different topic, but we need this in order to find something else. To find the distance between 2 points, there's a distance formula, but the distance formula is pretty much Pythagorean's theorem. I take 5 minus 2, I subtract my y values to get 3. I subtract my x values to find this distance, which is 6. Then I take 3 squared plus 6 squared equals distance squared, or 9 plus 36. This distance squared, so 45 is my distance squared, so this is the square root of 45. Or, and this we could take a 9 out of, so it'd be square root of 9, square root of 5, so that would be 3 root of 5. Now we're going to do the same thing to prove what we previously found, that the cosine of a minus b is cosine a cosine b plus sine a sine b. But this is probably going to be the biggest proof you have seen up to this point. So the first thing we want to do is, this whole angle here is angle A. So we'll call this cosine A, sine A. Remember, every point, the cosine is the x, and the sine of that angle is the y value. Over here, since this is b, we can name this point cosine b, sine b. So if I want to find this distance between cosine a sine a and cosine b sine b, I can say, I can subtract my x's and my y's. So I can even draw a little triangle here to find this value here. It's going to be cosine b minus cosine a. To find this value, it would be sine a minus sine b. And then so to write an equation, we have sine a minus sine b squared plus cosine a minus cosine b, or cosine b minus cosine a. Square that, and that's going to equal b squared. So when I expand this, maybe I should move this to the bottom. Well, let's try to do it here. When I expand this, that'll be sine a minus sine b times sine a minus sine b. plus, I'll move this to the next row, cosine B minus cosine A times cosine B minus cosine A, and that whole thing is still equal to d squared. And now when I multiply those across, I'm going to move this down here so I can have a long room. This would be sine A, which is going to be sine squared A. Here we're going to have plus sine A sine B. Out here we're going to have minus. Oh, these are both minus, so minus sine A sine B minus another sine A sine B. So that's minus 2 sine A sine B. My last 2 is going to be a negative times a negative is positive, sine squared B. And now when I deal with my cosines, cosine B times cosine B is cosine squared B. The inside is cosine A cosine B. The outside is negative cosine A cosine B, so that's negative 2 cosine A cosine B. And negative cosine times negative cosine is going to be positive cosine squared B. And remember, this is all equal to d squared. Now let's see if there's anything that we can simplify. We have sine A, sine squared A, and when I have cosine times cosine A cosine A, this should be cosine squared A. Alright, do you see that mistake? Cosine squared, cosine times cosine should be cosine squared A. So if I take sine squared A plus cosine squared A, that should just equal 1. So let's just write a 1 out there instead of writing these two values. I have a sine squared B and a cosine squared B. If I get rid of those, that would just be another 1. And then these two, there's not much I can do with. 2 sine A sine B minus 2 cosine A cosine B. Now, I could add the 1 plus 1 to get 2. But that's all I need for right now. Weird place to end, but we're going to continue with this in a second. But what we're going to do is we're going to take that same triangle that we got here. See how this was A minus B? I'm going to shift this triangle down to the x-axis. So this is going to be cosine of A minus B. This is going to be the sine of A minus B. And what's nice about this point is we can just use the point 1, 0, because that's right on the axis. Alright, so if I want to find my distance formula, I can make my right triangle, and I say this is 1 minus cosine of A minus B. Now I'll square that, plus sine of A minus B minus 0, so that's just sine of A minus B squared. That's going to equal that same D squared. 1 minus, now if we simplify this, I'll move it down here so I have one more room. 1 minus cosine of A minus B squared is going to be 1 minus 2 cosine of A minus B plus cosine squared A minus B. And this is just going to be sine squared of A minus B. It's going to equal D squared. Well, hopefully by now everyone sees the cosine squared plus sine squared of the same variable and knows that that equals 1. So 1 plus 1 is going to be 2, and now the 2 cosine of A minus B is what we have left over, equaling D squared. Alright, so we have this expression for D squared. We have this expression for D squared. I should have wrote equals D squared as I'm going along. So now let's see what we can do. We can use substitution to put those together. So how about I use a cut and paste? first, let's group it and copy. As I go to this next page, if I paste it, I'm going to bring it down here. So these two things are both equal to d squared. So I can use substitution to say 2 minus 2 cosine of a minus b is equal to 2 minus 2 sine of a sine of b minus 2 cosine a cosine b. I just use substitution since that's equal to that, and that's equal to that, and these two are equal. These two must be equal. So there's a few things we can do. The first thing that I see is I can subtract a 2 out of both sides, leaving negative 2 cosine of a minus b equals negative 2 sine a sine b minus 2 cosine of a cosine of b. Then I divide both sides by negative 2. And when I do that, I get the cosine of a minus b is equal to negative 2 divided by negative 2 is sine a sine b. Negative 2 divided by negative 2 is plus cosine a cosine b. And if you look at that, that sure looks like that equation. If you add the signs together, or multiply the signs together, multiply the cosines together, add those two values, that's going to be the cosine of a minus b. Now this is a crazy long proof. One of the longest proofs you'll see in this entire class. Hopefully you were able to understand it a little bit. Hopefully you understood it all. Alright, now we can use that formula in order to expand what we for cosine of theta minus 45 to write it as a linear combination of sine and cosine. So I could say this is 4 parentheses cosine of theta minus 45. So this would be my A, this would be my B. I could write this as cosine theta cosine 45 plus sine theta sine 45. Now, we all know that the sine and cosine of 45 is the same, which is root 2 over 2. So this is going to be y equals 4 times, this is going to be root 2 over 2 cosine theta plus root 2 over 2 sine theta. If I multiply this out, 4 times root 2 over 2 is just going to be 2 root 2. 4 times root 2 over 2 is also going to be 2 root 2. So this becomes, as a linear combination of sine and cosine, 2 root 2 cosine theta plus 2 root 2 sine theta. Alright, we can do it with this. Put a 6 on the outside. This is going to be cosine of A. Remember, this is your A, this is your B. Cosine of B plus sine of A, sine of B. So cosine 70, we don't know that. So what I can do is multiply that 6 over to each part. So I will multiply 6 times the cosine of 70 times the cosine of theta, and 6 times the sine of 70 times the sine of theta. This first part is going to be 2.05 cosine theta plus 6 sine 70 is 5.64 times the sine of theta. So I just wrote this first equation as a linear combination of sine and cosine. Alright, this is the last problem of the day. Let's see where I'm at. Alright, pretty far. Let's expand this. We have 5 cosine this is my A and this is my B. Oops. 5 should be on the outside of the parentheses. 5, and then it's going to be cosine 2 theta, cosine 210, plus sine 2 theta, sine 210. Now, if we, 210 is a nice one. It's over here. It's 30 past 180. So that's going to be 1, 2, root 3, with these two being negative. So the cosine of 210 is going to be negative root 3 over 2. And the sine of 210 is going to be negative 1/2. Notice we can't do anything with that 2 theta, it just stays where it's at. So when I multiply that 5 across to both with distribution, it's going to be 5 root 3 over 2 cosine of 2 theta. Now that plus and negative will just be a minus 5/2 sine of 2 theta. All right, we got through that one. And now here's your homework for tonight. Good luck.